Hello, and welcome to the Red Bank Humanists podcast. Each month, Red Bank Humanists hosts a public forum featuring speakers and topics covering a wide range of subjects of special interest to the humanist community. To learn more, including information about our monthly book club and our Drinking Post-Theologically events, visit redbankhumanists.org and follow us on Twitter at Red Bank Humanists.
Today we have a special guest speaker, Dr. Jan Dash, here today to talk to us about climate change and climate science, how it affects our lives now, and the ramifications for our future. One doesn't have to look too far down the list to see why we're all here today. The first one, we are committed to the application of reason and science to the understanding of the universe and to the solving of human problems. Another reads, we believe that scientific discovery and technology can contribute to the betterment of human life. And a bit further down the list, but not the least, we want to protect and enhance the earth, to preserve it for future generations, and to avoid inflicting needless suffering on other species. Jan Dash has a PhD in theoretical physics from UC Berkeley and has published over 50 papers in scientific journals. He was the director of research at the Center for Physics in Marseille, France. He is currently an adjunct professor at the Courant Institute of NYU. Jan is the Unitarian Universalist Climate Initiative Chair, and he was the editor of the Climate Statement Summary and Recommendations to Governments of the UN Committee on Sustainable Development, delivered to the leaders at the Copenhagen Climate Conference. Relevant to the economic impacts of global warming, Jan has also worked for 25 years in quantitative finance and risk management at financial institutions and wrote a book on the subject. Won't you please give a warm welcome for Dr. Jan Dash. Thanks.
Thanks very much, everybody. Okay, so thank you for inviting me here to speak with you today. I have about a 35-minute talk, and so I'd suggest that I do that first, and then we'll have a discussion afterwards. Is that okay with everybody? Yeah, okay. So, and then I also have on your seats, or some of your seats anyway, there is a handout about a website that I'm the managing editor for, and we managed to get it, at least the main page, up on the computer here so I can show it to you, and it's a great resource if you'd like to have a look. Okay, so the topic is climate change and what we can do about it. One of the things that I want to stress right at the beginning is a framing that is increasingly being used. It's being used for the reports that are starting to come out with this framing from both the IPCC, which I'll talk about in a minute, and the U.S. government, who is issuing reports on climate change. It's risk management. And risk management, if you don't remember anything from anything that I say today, remember this, risk management, because what we should be doing is the risk management of climate change. We deal with lots of risks. That's a risk, so we should deal with it. So risk management is a big deal. So I'll be giving you, first of all, a very high-level view of a little bit of the climate science. It's very complicated, but the basics aren't. Climate impacts, that is to say, what kinds of impacts do we now see that climate change is having, it's starting to emerge from the noise, and what are the likely climate impacts in the future. Risk management, which I talked about, and what we can do, and the what we can do part is what this stuff in the lectern is about, and so I would like to, talk about that. Okay, so, good. Okay, so the outline of the talk is, first of all, climate science. The most relevant fact is that there is a global warming trend of climate change. Temperature is going up. I'll show you that in a minute. It's been observed for about the last 35 years, and it's due to us. Simple fact. It's disguised and argued about, but it's a simple fact, and I'll show you the evidence. Climate impacts. There are many climate impacts We're starting to see some of these impacts now. They're almost all bad. You might wonder why some of them aren't good, and a few are temporarily good, but most are bad. And the answer to why they're all bad is pretty simple. So if I take the analogy that I use is this: the Earth is a very highly tuned system, like my watch here. Now, if I perturb the climate system, it's a little bit like dropping my watch. Now, what's the probability that I'm going to enhance the functionality of my watch by dropping it? I'm going to focus simply because it's in the news, not because it's the most important thing, on sea level rise, ocean acidification, and of course have to mention Sandy, and what can we say about Sandy, so I'll talk about that. Risk management, I'll say it again, I'm going to say it many times in the talk, and what we can do. And then there's an ethical question: why should we do anything? Right? Why should we do anything? It's unpleasant, but I have to talk about it. There is a huge disinformation campaign now with what I call pseudoscience, contrarians, deniers, science deniers. It's all over the right-wing press. I'm going to talk about that to analyze it a bit for you so you see what's going on. What do they say? Who supports them? And in that discussion, the word stranded assets will come up. And stranded assets are very relevant for the economic implications of why these people exist. And then the website that I talked about, if we can get a quick tour of that, that's fine. At least we have the front page up so you can see it. Okay, so that's the overview. So let's start. Okay, so first of all, have to start with observations. These are observations. They're not models. They're observations since about 1980, when the trend of the warming of the Earth began to appear from the noise. Now, before this, there are lots and lots of things that I could say, but because I don't have a lot of time, I won't do it unless somebody asks me about it. Here, what we see are these colored dots represent measurements from many different sources whose initials are listed here. These are basically all the data we've got. And what this plot has in it is subtracting out the natural variation noise from chaotic weather events like El Nino that heats the Earth, and La Nina, which cools it off, volcanoes, which temporarily cool the Earth off, and so forth. So when these, and the sun, which has basically been cooling off a little bit. So when these effects are taken out, these natural effects are taken out, this graph shows the temperature rise as a function of time since 1980 to last year. And you can see that although there's still a little bit of noise in it, the trend is up. There's no sign of any deviation here from the upward trend. That's global warming. All the natural variation has been taken out, so what's left is us. So this is it. This one graph is the statement that there is global warming and it's due to humans. Okay, so that's it for the climate science. That's all I want to say about it. Unless people want to ask me about it, I can talk about it. But if, that's all you need to know, really. So what about the impacts are practically all bad? I've said it before. I'll say it again. We see impacts now. We're starting to see impacts now quicker than predicted. But this is only a faint rumbling of what our children and grandchildren will see as they grow up in the future. Here's some example. Food stress on food. What happens is that at high temperatures, the yields of crops go down. That means less food. Less water. Glaciers all over the world, with a couple exceptions, but almost all the glaciers are receding. Snowpacks, including snowpacks in the United States and the West Coast, are decreasing. hundreds of millions, if not billions of people rely on glacier and snowpack water, and that's going to produce stress on water. More disease, why is that? It's because since the Earth is heating up, there's a heating preferentially at northern latitudes. So for example, insects that carry disease that would be killed off at high latitudes are not killed off anymore because it's warmer, so they migrate up from the south carrying their disease. War, the U.S. Pentagon is very concerned, and I'll talk about this a little bit later, about national security implications for the United States because of climate change. One example is because food and water will be stressed as we progress into the 21st century. There will be more conflict, and the Pentagon is very worried about this. Other examples, which I'll talk about: sea level rise, ocean acidification, and Sandy that I mentioned before. So we'll talk about that in a little more detail. I wanted to list these though first because these are the big ones. Food, this is what we have to have. We have to have food, we have to have water. Disease is a big deal, and peace. And so these are the really big ones, and I'm not going to talk about that anymore unless somebody wants to ask me a question about it, but I will focus now on these things. Okay, so I went to the Copenhagen Climate Conference in 2009, and there was a presentation by the U.S. military in the U.S. Pavilion at Copenhagen in the Bella Center. And the presenter was Rear Admiral David Titley, the oceanographer of the Navy, who's got a PhD in oceanography, very good guy. And online, through the internet, were representatives of all of the military branches, the Air Force, the Army, and the Pentagon itself, the Marines. And all of them were talking about national security implications for because of climate change. The U.S. Navy runs scenarios in their risk assessments for sea level rise of 3 to 6 feet on the average. So the sea level rise that's projected could be as high as 6 feet or 3 feet. It's been going up. If you read projections that were made 10, 15 years ago, they're less than they are now for a variety of reasons, which again I can talk about if you ask me questions about it. And so this is on the average. This does not include the storm surges or anything. These are data from NOAA. NOAA is a government agency that's responsible for this sort of thing. What you see here is sea level rise has been occurring, but it's going to get much greater. Is a much more than linear increase that's probably going to happen as we move into the 21st century. And it's projected that at the lowest, about a foot, and at the highest, about 7 feet by 2100. So this is huge. This is a really big impact. What should we do? Should we think, well, it could be only a foot, that's not a big deal, or should we say, well, it could be 7 feet, that really is a big deal. What should we plan for? What is the risk management action that we should take? How should we look at this? In terms of the connection with global warming, this one graph is a pretty good one. It shows sea level rise over the past 20 years, and on the same plot you have the temperature going up. Sea level's going up, temperature's going up. So what? Well, on the East Coast, we are especially vulnerable to sea level rise effects. These are so-called hotspots. You see all the way up and down the East Coast. They should not come as a surprise to anybody. There are other places in California on the West Coast. Florida is a big one down here and in our region. So we are susceptible to the impacts of sea level rise. One of the things that the U.S. military is extremely concerned with in terms of national security implications is migration, climate migration. So as the sea level rise occurs worldwide, many people, a large percentage of humanity lives by coasts, sea level coasts, and the reason for it is we used to use water as a means of transportation, and it's just easy. And then we have, just think about it for a second. Worldwide, we have all these cities that are right on the coast. As the sea level comes up, then many of these places will become unlivable, which means that people living there will have to move. Where will they go? They'll go inland somewhere, but other people are already inland. That means that there's going to be all kinds of conflict over land. So there's an expectation, which is not a hypothetical, this is real, that more wars will result. There's a quadrennial defense review from 2010, which is very good, which outlines all this. Small island nations are threatened. There are various islands in the Pacific which are basically geologic hotspots where these islands were formed by magma coming up from the seabed. These are just a few feet, often just a few feet above sea level. These are threatened with disappearing. And these people, when you hear them talk at the United Nations, for example, it's really heartbreaking. They did nothing to cause this problem, and their homelands are going to be wiped out by rising sea levels. Okay, so that's sea level rise. Now, as a kind of a parallel story in the ocean, not only are the levels of the average level of the sea going up, but something else is happening as well. So when we burn fossil fuel, as you probably know, carbon dioxide comes off as a byproduct. That's what's actually causing the global warming, along with feedback from water vapor. And most of the carbon dioxide actually goes into the ocean. Okay, so what? Well, from chemistry, you may remember, or perhaps not, doesn't matter. When you take carbon dioxide and mix it with water, you get carbonic acid. It's a weak acid, and it just stays there as acid. So the pH of the ocean has been changing to becoming more acidic, ocean acidification. Okay, so what? Well, the so what is that ocean acidification hurts the food chain, the marine food chain, in a variety of ways. One of them is that it attacks that algae, shellfish, and coral reefs, all affected in a negative way by ocean acidification. That's at the base of the food chain, means fewer fish. Okay? Now, so that's ocean acidification. The higher sea temperature, which is also occurring beside the sea level rise and the acidification, the sea is also getting warmer. And the reason for it is, again, a lot of the warming that is produced by us burning fossil fuel, that warming is actually in the ocean itself. And actually there was, somebody wants to ask me a question about it. There's a recent paper out showing that a lot of the very recent warming has been in the deep ocean, which is really scary because there's clathrates and other things down there which are not good. In any case, the higher sea temperature also hurts the food chain. It decreases phytoplankton, turns out. But fish eat phytoplankton, that means fewer fish. Hundreds of millions of people eat fish. There's going to be fewer fish. That hurts the food chain. So besides the crop problem with lower yields on land, it also is going to affect the marine food chain. Okay, so we've talked a little bit about the science. There is global warming. Sea level rise is occurring. Sea temperatures are going up. The oceans are getting acidified. And we've talked about kind of an average, on the average the sea level might go up a certain amount at a certain time. But there's more. And the effects on weather by increasing temperature due to global warming are also starting to become apparent. So you have to understand from the beginning, just a side comment, is that climate and weather from the beginning are kind of different. Weather is the noise that you see every day in a given spot. You know, today it's cold, tomorrow it's warm, it's cold in Chicago in the wintertime, so forth. That's weather. Other weather patterns are a little bit longer lived. I talked about El Nino, La Nina. Those are weather patterns that exist for several months, usually less than a year. But climate is kind of different. Climate is kind of on the average what you expect over a long period of time and averaged over large areas. So that's weather. So when I talked about the global warming trend, that's global, number one, and it's a trend over a long time. So climate and weather are distinct. However, it is now becoming apparent that the increase in temperature due to which is manifested by global warming is feeding back into the weather system, making weather extreme events more extreme. The reason for it is very simple. The reason is that global warming puts more energy into the weather system. There's more energy to do bad things. So it doesn't mean that we haven't had bad weather events before. Global warming just makes them worse. So that's the one-liner. Now, in terms of Sandy, there are a couple of things for sure before I get into the probabilistic part of it. The sea level has gone up some already because of global warming, and sea temperatures are higher than they used to be. That's also because of global warming. So it's certain that these two things enhance the impacts of Sandy. But there's more. There's more. This is a little complicated, but try to bear with me. So how many people have heard of the jet stream? That's good. Okay, so let me just remind you what the jet stream actually is. So in the north, we have the Arctic weather. It's very cold up there. And in the south, it's less cold, where we are now. Because of this temperature differential, it turns out that the jet stream exists. It's a band of air which circulates around the Earth, more or less like that, and the more or less is important. And what it does is it acts as a fence between the very cold air in the north and the warmer air in the south. Okay, that's what the jet stream actually is. Now, it turns out, for various reasons, that the Arctic is heating up faster than southern regions. So the Arctic is still very cold, but it's heating up faster than the heating is occurring below the jet stream. So the temperature differential between the north and the south and the Arctic and the non-Arctic region is not as high as it used to be. So the jet stream is not as fast as it used to be. Jet stream is not as powerful as it used to be due to this effect. What does that mean? Well, it means a couple things. First of all, blocking patterns are now more prevalent. That means the jet stream actually just sort of sits there. Parts of the jet stream, so there are parts of the air mass which don't move as fast as they used to. Those are called blocking patterns. That's number one. Number two, because the jet stream isn't as strong as it used to be, not only is it not moving as fast, but it's not as strong as it used to be, it means that there are meanders of the jet stream which come down from the north into the south, bringing the cold Arctic air with it. And this kind of effect was responsible for Snowmageddon a few years ago, and also the bad weather, very bad weather during the winter in Europe. You can't tell exactly where these meanders will occur, but they're becoming more frequent. And the connection with global warming is becoming more apparent. More and more, I read more and more reports about this, that there is, the data, we don't have a lot of data and so forth, but the thinking is that these two things are connected. So there's more jet stream instability, and so as everybody knows, when Sandy came up the coast, there was a blocking pattern that prevented Sandy from going out to sea, which would have been its normal course. Instead, it turned left. And so it is possible that, global warming has some effect in that way. Now, Of course, the usual disclaimer that you can't attribute any single event to climate change, number one. Number two, the attribution of how much worse did global warming make Sandy. We don't know that exactly either. It's a little bit like the old discussions about smoking, right? And so the defense of the tobacco lobby was, well, this person got cancer, but you can't prove that smoking did it. But that's, in a sense, is becoming more and more irrelevant. It's now becoming clear that global warming is having an effect on extreme weather, and so probably could have had some effect to make Sandy worse. Here's a picture of what I was talking about. Here's the jet stream. Here's a meander coming south. There's a blocking pattern. Here's Sandy coming up. So that's what I tried to say in words. Okay, so I've talked about climate science, that there is global warming. We're responsible for it. Climate impacts are starting to be observed now and are going to get far worse if we do not act in a robust and rapid way. And I've given you some examples. So now I want to talk about the risk management of climate, which I think is the central theme of this talk. First of all, I just want to tell you something. So this is my business. I do risk management. I've done it for 25 years. So in the industry, you talk about two types of risks. One is kind of an average risk. It's think of it as car insurance, where you're talking about comprehensive insurance, like a rock would go through your windshield. That's a kind of an average thing. It's not too it's bad, but it's not too bad, and it can happen often. Then you have what's called tail risk. These are less probable extreme events with very high impact. So that would be collision insurance, basically, that you're talking about, where there's and I've been talking about insurance a little bit, and that's a kind of a risk management that we do for driving our car. See? So the rational response to risk is, if you have any way to do it, is to lower it. So when you're driving your car, you try to drive in a way that will not increase your risk, generally. You hope, and to actually decrease it. So you drive on the right side of the road. You don't go into places which are, not too bad, and so forth. So lower the risk. And the best way to think about the response is risk management. Now, there's one thing that people talk about, which is business as usual. Business as usual means we basically don't do anything, or we just do a few things, but really don't act in a sufficient way to really mitigate the effects of climate change. And so under business as usual, BAU, what will happen will be today's extreme events, today's tail risk, today's high impact, low probability events will become more common, more average. So what seems extreme today to our children and grandchildren will become more common. Okay, so this is the what can we do part. So I want to start off in an optimistic way. I have to be optimistic. We have no choice. All right, we have to be optimistic because the alternative is unacceptable. So, and it's true that there has been progress. There is progress, and we can go through that. And I'm sure you know examples yourself. We just need more. It just has to be more. We just have to move faster. So there's action by individuals, very important. Energy saving, insulation, better insulation, energy efficient appliances, lights, LEDs rather than, all that's good. Anything helps. Scientists speaking out. I'm up here today, actually, and I just want to say the reason I'm up here today is not for me. I'm 71 years old. It's for my grandson. That's why I'm here. So scientists speaking out. So some of you are probably scientists. Think about it. Letters to the editor. That's a very important thing to do. Influences people. Politicians read them. So lots of action by individuals. Action by organizations. Corporations. Most of the economic activity in the world today is run by corporations. Corporations have to be part of the solution, and some of them are starting to think about climate change, trying to understand how much impact that they have in their corporations on climate change, and are starting to act in a responsible manner. There are some exceptions, notably the fossil fuel industry, which I will talk about. Universities, that's really big because the universities is where we're training our young people, and universities are starting to adopt, for example, carbon neutral efforts by a certain date, usually 2020, something like that. But the students are starting to pick this up, which is really important. Faith-based, I know this is not a faith-based organization, that's fine. We're all going to have to do this together, everybody. So everybody's going to have to work together. Faith-based organizations have a big role to play here because they can speak about the moral and ethical, just like you do, but in addition, faith-based, speak about the moral and ethical necessity to do something. All kinds of NGOs, so the Sierra Club, all kinds of NGOs at the United Nations, very important. And the media is extremely important because people's impression of what climate change is and how to act against it, or whether we should act against it, and what the cost is and so forth, is controlled by the media. So individuals, organizations, and government. Government has got to be a key part of this. We can't do it on an individual basis. We can't do it on an organizational basis. The government has to be involved, and the government has to be involved at all levels. That means city governments. So, for example, in Middletown, we have a green team. They don't do a lot, but there are actions in other cities. Chicago, for example, has a very big city program. Mayor Daley, Jr. has instituted a very big program. Los Angeles has a very progressive program. New York, with Mayor Bloomberg, has a program. There's something called the 40 Cities program. It's very important, and cities from around the world are taking the lead in many ways in climate change action. State level. So at the state level, there can be state programs. For example, New Jersey has a clean energy fund, which the mayor has unfortunately been raiding to feed the state coffers, but state action is also important. Regional action, for example, there's a RGGI cap and trade program for Northwest states. National government, national incentives, and so we can talk about national incentives in the United States. International efforts through international conferences and treaties. There is now an agreement by governments to create a climate treaty by 2015 that would be hopefully ratified by 2020, something like that. And then regulatory by the EPA. And now I just want to pull all this stuff out. So one of the things that, in spite of my bad back, I lugged here for everybody to have a look at. This is a report by the IPCC, the International Panel on Climate Change. This is their 2007 report on mitigation, what we can do. So if people don't know, what can we do? I just can't think of anything. Here you go. So what I'm going to do is, if somebody could put this on the back table, I encourage you to have a look at it. Okay, thanks. Then just a couple of quick announcements. I'm with the Unitarian Universalist Congregation of Monmouth County on Front Street. There's some events that we're having next week, which I want to invite you to. It's, first of all, having your home screened for solar installation, if you're interested in that. There is going to be a showing of the movie Bitter 70. You might have heard of Tim DeChristopher. There's a movie made about that. And then there's going to be a representative from New Jersey Natural Gas at the congregation at the forum there at 9 o'clock next week, talking about tax breaks given by New Jersey Natural Gas. And then the service will be Fletcher Harper of Green Faith, speaking on investing and reinvesting and connection with climate change. So if you could put these back on the table also. And then I want to talk about one more thing, which is that I'm with the Unitarian Universalist United Nations office. I'm the climate Initiative chair. And we are going to start trying to spark the creation of climate action teams nationwide, climate action teams in congregation. If you guys would like to have a climate action team, I could help you set it up. So what would the climate action team do? Well, one of them is educate people on links between climate change and other social justice issues. Social justice is a big part of what you do. So there is a connection of how climate change would impact human rights, poverty, inequality, intergenerational equity, that's your grandchildren, immigration, women's rights, and so forth. Oh, thanks. That's very helpful. Climate bulletin board. Start a climate bulletin board. Show people what the news is. And then train, and this is really important for scientists, to train to understand and be able to rebut the contrarian denier fallacious pseudoscience, which I will talk about also. Adopt a climate statement. Set up a letter writing activity for letters to the editor. Politicians really read these. They're really influential. They're really helpful. And you know, there's lots of things to do. So I have a one-page flyer here. Maybe I'll send a PDF to you, and you can distribute it. It's phrased in the language for you use, but it applies. It's universally applicable. Okay, so that's what we can do. So what's the one thing that we could do to stop the impacts of climate change? What do you think? What's the one thing that we could do? Well, the answer is there isn't a one thing. There's no silver bullet. And so there's going to be, I indicated that you have to have action by across the board by organizations, individuals, and in a number of different areas. So what we're going to be looking for is not a 100% solution, not the silver bullet, not the one thing that'll fix everything. That won't happen. The way it will work is, if we are successful, is there'll be a number of 5% effects. Look, if you have 25% effects, 20 times 5% is 100%. That's how you get to 100%, not just one thing. There are actions called no regret actions. You can say, well, what if all the scientists are wrong? What if there's no impacts of climate change? Maybe climate change is all good, and we'll spend all this money and just waste it. Well, first of all, you start with no regret actions. So insulation, better car efficiency, things that you would want to do anyway, right? And one really important thing is we need to mitigate, and we still have to have energy. We cannot go back to living in caves. Nobody will accept that. And so we have to do this in a way that makes sense from an energy point of view. Non-fossil energy, moving to non-fossil energy from fossil fuel. I also want to talk about, for just a second, something called the Citizens Climate Lobby. Has anybody heard of that? Citizens Climate Lobby? Good. Okay, Citizens Climate Lobby is a very directed group of people that focuses on interacting with at the national level, national legislative level, with the House of Representatives and senators, to try to get a carbon fee and dividend going. That means that you would basically tax the carbon production at the source when you're mining coal, or you have oil wells or natural gas. And then what you do with the money is you distribute it back to everybody on an individual, equal basis. So there's no net revenue to the government, and it all gets distributed back. Why do this? Well, it is a price on carbon that you need in order to do two things. First of all, recognize the cost of the impacts of it that fossil fuels are having, that I talked about before. It's their impact, so they should pay for it, right? Or you should pay for it if you're using something that's destructive, number one. And number two, it will give renewable energies a chance. Okay, so I've talked about the science. There's global warming is due to us. I've talked about the impacts, number of impacts that are starting to be observed now. Will get worse if we don't do anything. I've talked about what we can do. But why should we do anything? Why should we do anything? Well, if you have an idea of justice, if you think about the poor are having the smallest impact on climate because they don't use much energy because they're poor, but yet they're going to suffer the worst because they're the most vulnerable and have the least ability to adapt. But I want to emphasize that there's no place to hide. People sometimes get the idea, well, we're talking about Africa. Africa will get hit very hard. We're talking about small island nations. Yes, they will get hit very hard. But the United States will get hit very hard, too. We will get hit very hard. There's no place to hide. And then finally, why should we act? So it's a matter of justice, survival. Survival is what I would call this. And intergenerational ethics. And I talked about my grandson. All the children, they are doing nothing to create this problem. We have a responsibility to leave them a world which has the hope of being a decent place to live. And it's more humane on the long run and cheaper for preventative action now than for them in the future to have a disaster adaptive action. They will thank us if we try to solve this problem, and they will curse us if we don't. Okay, so what about the cost? Well, you could say, well, okay, so there is a cost to mitigation. Maybe it's too much, Well, it's only one side of the coin. What we need is a cost of climate impacts, and then compare that with the cost of mitigation. There's a technical thing about a discount rate. So a discount rate is a rate that you use to discount cash flows in the future or impacts in the future, and there's a lot of debate about the appropriate discount rate to use. There's a financial point of view, and then there's an ethics point of view. Basically, by having a discount rate, you're discounting the effects on your grandchildren. So I just want to bring that up. Okay, so I'm probably running out of time here. I just want to say a few words about the climate science deniers. And basically, they fall into 4 categories. First of all, some of them still deny that global warming exists. Basically what they do is they look at little glitches in the temperature record and draw little local lines and say, well, there's no global warming. Or they'll deny the human influence on climate change, global warming, by pointing out irrelevant things that happened in the past. Actually, when you do look at the past record, long before human civilization, you get a picture that shows what happens if you do increase the amount of carbon dioxide in the atmosphere, and it's not pretty. They minimize the climate impact risk. For example, they'll say, well, if temperature goes up, carbon dioxide goes up a little bit, it's good for plants, it's plant food, right? Well, sort of, but then, as the temperature keeps going up, the plants die. So they'll point out something which is only partially true. And they'll exaggerate the cost of climate action and mitigation. It's something which they do all the time. They oppose climate action and renewable energy. Basically, all of this is a deliberate tactic that comes from the tobacco, the fight over cigarettes, and is well documented by Naomi Oreskes. She has a book which is very good. Basically, they have 2 things that they do, which is both of them are treating science as if you're in a legal argument in a courtroom. They say, well, you can't prove anything using science. Well, that's true. Science never proves anything. Only in mathematics do you prove anything. Never in science. Science never proves anything. There's only more or less evidence. So they say, well, science can't prove it. Red herring, straw man, so we shouldn't act. Okay, that's the first thing they say. Second thing that they do is they'll cherry pick information, propose flimsy arguments that have no chance of being right, or just a tiny chance of being right. They'll say, see, it could be this way, so we shouldn't act either. So that's what they do. Let me give you a quick example. This is a chart that shows Arctic sea ice extent. Does not tell you about the thickness of the sea ice, which is also really important. That's been going down, but it shows you the extent. And the blue line shows you the sea. This is as a function of what month you're in. So in the summertime, the sea ice goes down, right? In the wintertime, it goes up. And this shows you that in 1989, this is how much sea ice there was. And in 2009, this shows you how much sea ice there was. So you would say that the sea ice has been going down, right? That's on the whole, the trend is that the sea ice has been going down, and you can see pictures, and it's very obvious. However, there's one point here. One point. For some reason, we don't know what it is, some noise, something happened. Got a little colder or something in 2009 locally. And so 1 point is higher than in 2009 than it is in 1989. So what the deniers will do is they'll say, look at that, first of all. But they won't say, look at that, because they'll never present the graph. They'll simply say, sea ice is not decreasing. That's what they do. And that's repeated over and over and over again in many different ways. That's exactly what they do. So are they lying? Well, technically, there is this one example, but, they're cherry-picking information. So actually, yes, they're lying. Here's a kind of funny story you may have heard. Anybody hear about the North Carolina legislature? Okay, so anybody know who Canute the Great was? Canute the Great was a ruler of much of Scandinavia 1,000 years ago, and he, for various reasons, took his throne down to the beach and pointed at the sea and said, "Do not rise." And after he got wet, he, so this is a history. There's some color to it, and if you want me to talk about it, I can. But that's the basic structure. This is a coin with him on it. Okay, and the North Carolina legislature recently tried to pass a law that said that they would not take into account scientific predictions or indications of the rise of sea level, to just use historical information. So I guess they didn't really read their Canute the Great history very much. Who supports the contrarian deniers? So this is the one slide about the stranded assets that I want to talk about. So it's basically the fossil fuel companies, and the fossil fuel companies want to be able, they have resources. They have coal in the ground, oil in the ground, natural gas. They want to be able to bring that up, these are assets, and burn them, because that's what creates value for them. If for any reason, legislation or regulation, whatever it is, they are unable to, or even if they could do it, they're not allowed to bring up these assets out of the ground and burn them, then they are called stranded assets. They are of zero value to the fossil fuel companies. They cannot sell them. They're sitting in the ground. They are assets, but they're stranded assets. So this is beginning to hit the news. This is starting to hit the news now. There are these very stranded asset calculators showing how much the stock price of a fossil fuel company would decrease if the existence of stranded assets were taken into account by means of future legislation or regulation. And it's huge. It's absolutely huge. It's, I've seen calculators where it's a factor of 2. So in other words, we are in a carbon bubble, it's called, and without recognition of the cost of impacts or what we have to do to reduce the carbon impacts. And so this would reduce the fossil fuel companies' wealth and their stock price. So this is the economic reason, and these people are the people that support the climate deniers. So these climate deniers are a bunch of what Carrie Emanuel at MIT calls mavericks and charlatans. So why would they be supported? Well, they're supported basically because they're front people to get out in front and try to create the doubt to try to prevent any legislation or regulation of stranded assets. We also have libertarians, the Tea Party. So this is not independent of the fossil fuel company. David Koch, who's with his brother, their combined assets make them the wealthiest people in the world. And David Koch did found the Tea Party. Oops, I misspelled Fox News. I'll have to fix that. Okay, basically what these people do is they basically oppose government action. And governments have to be a part of the solution. They know this, and they basically oppose government action. And so they simply try to kill the message. It's as simple as that. Okay, here are some resources that I mentioned. There's the IPCC. There's a science report. There's an impacts report. And there's the mitigation report, which is back on the table there. This is the United States National Climate Assessment, which is a report that is mandated by Congress. And there's a global sea rise scenarios. There is a very good website called skepticalscience.com, which has one-liner responses to contrarian arguments, which I recommend. I'll just show you real briefly the UNO Climate Portal, and there's the U.S. Quadrennial Defense Review. Okay, so this is, so on your chair, everybody should have a copy of the UNO Climate Portal. So here it is. There are buttons on the side there. I'm not going to run through it because there's no time, but there's buttons on the side there. Basically, it's a soup to nuts website. What can we do? All kinds of things that I talked about. They're all detailed here. Resources, articles, news. I have about 50 RSS feeds that bring back news, climate news every day on the portal, so you can see what the latest news is. Here's some of the articles. Okay, so that's it. So let's go back to the talk. So I just wanted to, yeah. So because I'm running out of time. Okay. Okay. Good. Okay. So, okay. So I talked about that. Okay. So what's the bottom line? Well, we have a big problem, everybody. We really have a big. It is really big, and we can solve it. We have to be optimistic. There's no other choice. Human activities are causing the recent global warming trend of climate change. That's what's behind all this bad stuff. Climate impacts are almost all bad. They're observed now and will become far worse if we do not act in a sufficient way. Climate action is opposed by very strong forces, but it's not too late to prevent the worst aspects, and you can help. Thank you.
We've got about 20 minutes for question and answers. Thanks for the lights. What we do here normally, everyone knows, I'll walk around with the microphone, so we do it one at a time. So raise your hand if you have a question or a comment, and I'll try and keep track. I can only count to 5, unfortunately. But I'll start right here. So you two back there over there.
I have a question on the percentage that the human contribution to the increase in temperature that you had on the first graph. That's what I had looked at. Do you have as a percentage, a rising percentage as compared to natural contributions to global, temperature rise?
The entire rise is due to humans. The natural effects are effects which produce noise, and they go up and they go down. But on the short term, over the last 35 years, it's thought that practically all of it is human-induced. Very little. It's not due to the sun, because the sun has actually been cooling off slightly. Volcanoes only act over a period of a few years. It depends, there's one thing that you have to be aware of. It depends on the time scale you're talking about. If you're talking about 1 or 2 years, then natural fluctuations can dominate. So, if, for example, in 1998, there was a huge El Nino, the biggest El Nino of the century, 1997, 1998. So what climate contrarians will do is they'll point to that, and they'll say, look, the temperature in 1998 is as big as it is now, is as high as it is now. That's actually false, because it's a little bit higher now than it was then. But that was due to a natural fluctuation. And it has nothing to do with the trend in climate change. So when those effects are taken out, then the rise is basically entirely attributable to us. You can also look at climate models. So in climate, I haven't talked about climate models, but climate models are actually a very reliable source of information. And they show that so in a climate model, you can turn off human effects, and you can also turn off natural effects. If you turn off human effects, there is no way that the models produce anything looking like the rise in temperature that we actually see with instruments. If you put in human effects, then you do see the rise in temperature, pretty much with some uncertainty, but pretty much following the trend. So it's due to us.
Is there any specific part of the world where it produces the most problems for climate warming?
That's a really good question, and the answer is yes. The answer is yes. It appears that the northern hemisphere is warming more than the southern hemisphere. That's due to 2 reasons. First of all, there's more land. Land heats up faster than water. So there's more land in the northern hemisphere, so the northern hemisphere is heating up more than the southern hemisphere. And the second is that ocean currents are carrying warmer water from the south up into the north. So there's a big conveyor belt of ocean currents. That's the 2 reasons. The third point, which is that if you look at the very northern part of the globe in the Arctic, that's heating up faster than anything else, and that's responsible for this for this possible increase in extreme weather. But the basic idea is that yes, it's there are also regional effects. So regionally, it is possible that some areas will heat up more than other areas. One of the big problems in the United States is the Southwest. So we're talking about the area just east of California and north of Mexico. And that's expected to really heat up more than the average with severe drought consequences.
Given the enormous problem that we have with climate change being generated by human activity and the really small effort to mitigate it at this point, what do you think the implications are for the survival of the human race?
I am optimistic.
Because you have to be. But, excuse me, this is something that people don't talk about, but it is indeed a possibility.
All of us in this room have a responsibility to go out and talk to people, write letters, do what you can.
My question is, what's the current status of efforts to take the carbon out of the atmosphere? I know there have been some efforts, but you don't hear much about it these days.
Yeah, so he's talking about carbon sequestration. So if we have carbon dioxide in the atmosphere and it came from under the ground from the fossil fuels that contained it, why don't we just put it back? And so there have been a number of efforts to try to carry out research projects to do that. There are some small-scale efforts that have been successful in Norway. I know there's an effort which has been successful to try to sequester the carbon dioxide under the ground. Nothing on a big scale, and there was a very large project in the United States that I don't think was renewed. I think you have to have carbon sequestration of one sort or another. If you're not going to take it out of the air and store it in caverns underground, then you need more plants to absorb it. Something has to happen, and the answer, and the reason that you need it is very, very simple. Right now, there's over 390, and don't worry what the units are, it's parts per million of carbon dioxide, but you don't have to remember that. It's just remember 390. And it's known from paleo data that when the level of carbon dioxide was somewhere around, and we don't know exactly, 425 plus or minus 75 parts per million, there was no ice on the planet. No ice on the planet means a sea level rise of 25 meters. How long would it take the ice to melt? Well, estimates have been going down. People used to think thousands of years. Now I'm seeing 8,000 years, maybe 100, so because glaciers can slide off the Antarctic shelf, or water can come in from underneath, and so there's all kinds of effects. There's moulin of water that goes down and greases the bottom of the glacier, so they slide off into the ocean. So there's all kinds of reasons why this has been speeding up, but the basic point is that if you take 425 and you take the error plus or minus 75 and you subtract it for risk management purposes, you get 350. That's where 350 parts per million comes from. That's where 350.org comes from. Okay, so anybody here of 350.org, James Hansen? Okay, so that's where that number comes from, what I just told you. Now, if you now ask how much carbon dioxide is up there now, well, it's more than 350. So from a really strict risk management viewpoint, in order to be safe, quote unquote, of having the ice not disappear from the planet and having sea level rise eventually go up 75 feet, then what you need to do is to take 40 parts per million and stick it back under the ground, right? Because there's 390 now, we need 350 to be safe, so stick 40. So that means that from that point of view, carbon sequestration is unavoidable. We need to have it. And and then then there's all the question of how much does it cost, can you do it safely, how are we going to do it, and so forth. But yes, carbon sequestration is discussed, and it's important.
Jan, thanks. That's one of the best talks I've ever heard on climate change.
Thank
and
you.
I just wanted to mention we will be putting your talk with the slides on Red Bank Humanists YouTube channel, so people will be able to send the link to your talk to their friends.
Great.
I had two questions, and the first one is only partially frivolous, but don't the Koch brothers have grandchildren? And I wonder if anybody's thought of, giving a special presentations to people like that who have the resources to strongly influence, to get some of them to sort of switch to the other side. My second question has to do with the deniers or the skeptics. I'm not a skeptic, but I have a friend in Texas that I share a lot of email with. And when we talk about things like the acidification of the ocean, he will bring up things like, well, look, in the past, natural selection has led to the flora and fauna that we have today. And as the ocean acidifies, won't that select out those creatures and phytoplankton and so on that will do better in a more acidic ocean and so on? So there will be a change. Some things will go extinct, but they will be replaced by new species. And I just wondered what your response to that would be. Thanks.
So two excellent questions. Let me try to deal with them first. I do not know if David Koch has any children or grandchildren. One of the problems is that I believe that these guys actually start believing their own Kool-Aid. I don't know what the expression is. David Koch, huh? Drink your Kool-Aid. Okay, have to remember that. Drink your own Kool-Aid. I don't know why it's Kool-Aid. What? Oh, Jones. Oh, that. Oh, yeah. All right. So David, it's interesting with David Koch because he at one point was trying to, I think, show that private individuals could sponsor scientific research. You didn't need the government for it. So he was actually trying to take over science in a way. So he sponsored something called the BEST study. Anybody ever hear of the BEST study? Oh, okay. So the BEST stands for, well, it sounds like best, and so that's probably why you need it. That was the Berkeley Earth something is what it was. So this was an effort by people to take climate data that were already there and then reanalyze these data to try to see if they would come up with any other conclusion than the mainstream scientists had come up with. And they hired a guy to run it named Richard Muller. Now, Richard Muller was a climate skeptic. He's actually a physicist, I'm sorry to say, and he teaches at Berkeley, which is where I graduated from, so I'm sorry to say that too. But he published an article once in the MIT Technology Review, which is completely wrong. And he was a climate skeptic. I hate to use that word too, because scientists are skeptics, but these guys are false skeptics. But that's what they call them. And so he ran this thing, and then finally, in the end, he found out after looking at it in detail that yes, there was global warming, and yes, humans caused it, and he went public with it and announced that he had been wrong. So that was good. That made a big splash. I guess it happened a year or two ago, and then that all kind of died down. And so I don't know what David Koch really thinks, but I do know the one thing that he is really concerned with is stranded assets. So whatever he thinks, and I don't know exactly what it is, one thing that he is influenced by the fact that his stock price, his wealth, which is now $40 billion, will go down by a factor of 2 if stranded assets really exist, and he doesn't want that to happen. So, is he concerned with his grandchild? Well, with $40 billion, you can do a lot to protect somebody. So that's the way I think he probably thinks about it. All right, so that's that. However, it's a really good issue because there are more and more people that with a lot of money that are starting to ask climate questions. There is a group of investors that controls over $20 trillion that is starting to ask questions about fiduciary responsibility, about corporations and what they're doing about climate change, because their money is at risk. Get it? All right, so it may be that the real effort in climate change mitigation will come from the investor side. Okay, so that's one thing. The second thing is about species extinction. That is a really important topic. I didn't bring it up, but that it is expected that if things go the way they're going, that some sizable fraction of species living today on the Earth will become extinct, and so then the comment is, well, yeah, but you could always have new species, and yeah, you're right. So let's say that instead of fish, we have more weeds. Next question.
Is there someone over here?
Yeah. What is cap and trade, and should we support it or reject it?
Cap and trade was a market-based approach, which was instituted because of something called the Kyoto Protocol, which is an effort to make carbon, to put a price on carbon through trading, and it's a system that exists mostly in Europe, and also has some limited there's some limited cases in the United States. I mentioned RGGI, which is a cap and trade system in the Pacific Northwest, and there are other examples. Basically, what it does is it puts a price on carbon through some technical financial ways, and then these things that exist in the carbon emission trading system are then traded. And the problem with it is there are two problems with it. The first problem is that there's nothing to really support a minimum carbon price with it. So the price of carbon is probably should be something like $50 to $100 a ton. And right now the price, I haven't looked recently, but the last price of carbon in Europe has dropped a lot, and I think it's somewhere between $5 and $10 now. So there's no minimum price of carbon which is guaranteed. The second thing is that, as any market solution is, it's subject to manipulation and so forth. And so it's now thought that a better way my feeling about cap and trade is we need all the help we can get, and so we should support this and everything else that has a possibility of helping. But a more effective way will probably be the carbon tax and dividend if we can actually get it going.
How do you respond to deniers who point out about ice age and warming of the globe before human beings significantly impacted the climate? Second question is that people point out that developing nations such as China are increasing their carbon dioxide emissions so much that even if U.S. Stops producing carbon dioxide, we are still in a bad shape.
Two excellent questions, thank you. So the first question has to do with historical climate changes relative to climate changes today. And so the answer is yes, climate has changed in the past. It's changed a lot. It's changed because of natural effects, because humans were not there burning fossil fuels. That's exactly correct. However, humans are here today. We are burning fossil fuels, and so we are influencing the climate today. Both things are true. So that's the first thing. There is nothing in climate science that says because something happened in the past a certain way, the same thing is happening today. That's the fallacious link that the deniers will try to promote. Second point is that is with China, and so let me just bring up three facts. First fact is that China, as a country, is now producing more carbon dioxide emissions than the United States. That's the first fact. Second fact is China has 3 times as many people as we do, so per capita we are still emitting more carbon dioxide than the average Chinese person. And the third thing is that if you look at the integrated amount of carbon dioxide in the atmosphere, then the United States and Europe are responsible for about 60% of it, and China is responsible for about 10% of it. So these facts have been at the root of why it's been so hard to get an international climate treaty, because the Chinese and other developing nations will say, well, look, there should be, you guys, meaning us, used all this fossil fuel energy to get your society to the advanced state where it is now? Shouldn't there be energy equity? Shouldn't we be allowed to do the same thing? So, then you say, well, yes, but there's a problem with carbon emissions, and so their response to that is, yeah, but we have the right to develop too. So that is the official stance of India. China is right now is a kind of a schizophrenic place. What they are doing is, first of all, they are building basically every week a dirty coal plant, which is like the worst. And second of all, they are leading in renewable energies. So I think their approach is to build the coal plants and then get into renewable energies as soon as they can and replace the coal. I think that's what they're trying to do. Actually, today there was a joint communique that came out between China and the United States, which I thought was very positive about cooperating on renewable energies. It's a real problem. However, we have to act anyway.
Okay, we're going to have 3 more questions. It's about noon right now. 1, 2, and this gentleman back here had a question.
Dr. Dash, nuclear energy, everybody cringes when you say it because of its high risk and the disposal. I was recently told that nuclear plants could be constructed using the element thorium rather than plutonium, and that it would be essentially go from high risk to almost no risk for all the negative effects of nuclear energy. Do you know anything about that, or is that true? Or
so, nuclear energy is a big controversial part of all this. Of course, conventional light water reactors have an advantage that they don't burn carbon dioxide. That's good, but there's a disadvantage, a number of disadvantages in terms of the possibility of nuclear proliferation with waste, and nobody will insure the plant. So it means that there has to be a government backstop, which means us, to backstop the nuclear industry. So it appears that for all practical purposes, the current technology of light water reactors, for whatever reason, is not going to continue. There are a number of research efforts in the pipeline, and they go under the name of basically 3rd or 4th generation nuclear reactors. They're much better than the current crop of nuclear reactors. First of all, they eat radioactive waste produced by the current crop of reactors. That's good because it can be used to reduce the amount of waste that we have now and reduce nuclear proliferation. And so those are very good. They're fast neutron reactors. They're very expensive. They're in the research stage. They should be supported. They're not ready to go. It's a difficult topic.
Yes, I've a lot of people talking about carbon dioxide, but no one seems to talk about methane, and there are other factors like the fact that as the ice sheets are thawing, it's reflecting less sunlight back out of the atmosphere. So it seems like as like the permafrost starts to go, that the methane will accelerate things even much quicker than we expect. Plus the amount of people, for instance, even cow burps and people, emitting waste, human waste. All that adds up too, and it never seems to be calculated into anything, except with carbon.
Good question. Methane is a big deal. Carbon dioxide is worse, but methane is a big deal. It is included in all the IPCC calculations and so forth, so the scientists do talk about it. I was sitting at dinner one time I went to Caltech, and so I was sitting at a Caltech dinner with a guy from the geology department, and we were talking about climate change, and I said, what really scares you? And he said, what really scares me is methane. What really scares me is methane, because it's frozen in the, so what we have in the permafrost, which is the frozen regions in the north, we have carbon, which is simply frozen. It's simply frozen. It's there. Also underneath, on the bottom of the oceans and deep lakes, we have methane in the form of what are called clathrates, or ice crystals that contain methane. There was a huge event called the PETM event that happened 50 million years ago, where for some reason a huge amount of methane came out from under the ocean and warmed up the planet, in a dramatic way. So one of the things that scares me is when I start hearing about more heat going into the lower oceans is, what about the clathrates? I have to, methane right now is a fraction of the carbon dioxide emissions. However, methane is important, and we should worry about it, and there we are.
All right, this is going to be last question. So I'll let you guys fight over.
How can we fight by being nice and writing letters to the editor so that the politicians read them in face of a crisis brewing like this, and fight Koch brothers' contributions to politicians of $100,000 per election? How can you achieve anything, and why not instead target Koch Industries as ourselves, because we're buying their products with brownie towels, with Angel Soft tissue, and many other things like Lycra that are in our sheet. So we're actually supporting their destructive behavior. So that's what I'm wondering, if letters to the editors is going to be enough, or shouldn't we do something more radical?
That's something which is being debated now. One of the events, which is a flyer back there, is an event about Tim DeChristopher that did take some action. You can hear about it. You can see it in the movie. I think the big issue is in people's minds, and so whatever means can be used to tell people if there is a problem, there are going to be really bad consequences, and you can do something about it. If we can get that message out, then and eventually that message will get out, and here's why: because eventually the effects of climate change will become so apparent, they'll become so obvious that even David Koch will change. When will that happen? How long will it take that to happen? In the meantime, what I would urge all of us to do is try to act. How about a climate action team, everybody? Get other people to do it. Go out and talk to people. Thank you very much.
Thank you.
Thank you for listening to the Red Bank Humanists podcast. For more information, visit redbankhumanists.org or follow us on Twitter @RedBankHumanists.